Hi, my name is Patrick Reagan. This series of videos, Computer Electricity and Electronics, will explain what is electricity and how it affects the computer and various electronic components that are heavily used in computers. This series is a prelude to taking a computer apart, since you need to learn about how electricity powers the computer and how to work safely with electricity before taking a computer apart and putting it back together. The last thing you need to do is electrocute yourself or damage the computer. The first video of the series is called Introduction to Electricity, defines what is electricity and where it comes from. It will define conductors, insulators, semiconductors, electrical circuits, electrical loads, open, shorts, and ground, which will give you some background information that is key in troubleshooting electrical problems that are affecting computers. Lastly, we'll discuss what is AC and DC power and their differences. Let's start explaining what is electricity and how conductors, insulators, and semiconductors interact with electricity. Atoms make up everything. It consists of protons, neutrons, and electrons. The core of the atom is made of positive charged particles called protons and neutral charged particles called neutrons. Electrons are negative charged particles that circle around the core. Under certain conditions, the electrons are pushed from atom to atom, which we know as electricity. Electricity is a form of energy that occurs naturally, and such as in the form of lightning, or is produced such as with a generator. In fact, it is one of the most widely used forms of energy that is used for lighting, heating, and cooling homes, and it powers televisions and computers. The electronic devices are made of conductors, insulators, and semiconductor material. A conductor is material in which electricity flows through it easily. Most metals are good conductors, including silver and copper. In fact, copper wire is the most commonly used conductor because it's inexpensive and a good conductor. While distilled water is a good insulator, water with charged ions and impurities can be a good conductor. Most water that you encounter has charged ions and impurities, including the water you drink. Hopefully you already know that you should not mix liquids, including water, with electricity. Many people have said goodbye to their computer, phone, or other electronic devices because their devices got wet, and how many people have gotten shocked when handling devices mixed with water. In the United States, there are over 400 electrocutions and over 4,000 non-fatal injuries every year in the United States alone. An insulator is a poor conductor of electric current. In fact, insulators like rubber are used to contain electricity and prevent electricity where it is not wanted. When you have a power plug, the metal conducts electricity, while the rubber exterior allows us to hold the cord and to plug in and pull the plug from the AC electrical socket without being shocked or electrocuted. A semiconductor is a material that is neither a good conductor of electricity nor a good insulator. However, when electricity is applied in a certain way, they can have some unique properties, including limiting electricity to only flow in one direction, to amplify a signal, or acts as an electronic switch. Computer chips such as microprocessors, RAM, and motherboard support chips are composed of semiconductor materials. Now that you understand what electricity is, let's talk about what is voltage, resistance, and current, and how they relate to each other. Voltage is the force that pushes electrons from atom to atom, which causes electricity to flow. In electronic devices, electricity is generated by a power supply or a battery. It is sometimes referred to as a voltage drop or potential difference, as voltage will flow from a high voltage point to a lower voltage point. Voltage is measured in volts. Resistance is the opposition of current. Components that are specifically designed to oppose current are known as resistors. Resistance is measured in ohms. If you measure the resistance of a copper wire, you should measure 0 ohms because the copper wire is a good conductor and has, for all intents and purposes, no resistance. If you measure the resistance of a rubber shoe or a rubber outer part of the cable, the resistance will be high since rubber is an insulator. Current is the rate of flow of electricity, which is measured in amps. If you remember, voltage is the force that pushes electrons in electricity. If you have more voltage, you have more force, which means you have more current or electricity compared to if you have less voltage. If you have more resistance, less current or electricity will flow compared to less resistance. One way to look at voltages is by comparing electricity to water flowing through a pipe. If you have a lot of pressure, more water will flow through the pipe as it pushes water faster through the pipe. Voltage is the pressure for electricity. If you have a bigger pipe, you have less resistance, so more water can flow through the pipe. However, if you use a smaller pipe, you increase the resistance and less water will flow through the pipe. Power is the rate of energy consumption or the amount of energy used in a certain length of time. In electronics, it is expressed in watts. When you have a power supply that provides power, you cannot exceed its power provided by the power supply. An overload is if you have too many devices connected to a power supply or battery. The power supply or battery will not be able to provide enough electricity to the load. The computer power supply will shut down if it is overloaded. A typical computer power supply will be rated between 250 watts and 850 watts, which means that this is the maximum amount of power that the power supply can provide. If you exceed the capability of the power supply, the computer will shut down or reset. On occasion, I will look for the amount of wattage of a specific device uses, and the information is not readily available. In these situations, I will find the voltage and amperage rating or current of the device, and I can calculate the power consumption by multiplying these two values together. This will not be on the A+ exam, but it can come in handy. Next, we discuss an electric circuit and load, explain how ground relates to electricity, and explain common electrical problems including opens, shorts, and overloads. For electricity to flow, you have to have a complete circuit, which creates a loop. This is the reason that a power plug has two metal prongs and two wires, one for electricity to run into the device and one for electricity to return. The voltage source, including power supplies or batteries, and electronic components are connected with a conductor such as a wire or metal trace to form a circuit. Electrons leave the voltage source through the electrical path to the electrical load and returns to a common return. The ground is often used as a reference point in electronic circuits. A circuit can be broken down to its elementary blocks that include 1. A power source such as a battery or power supply, 2. The path such as a wire or metal traces on a circuit board, and 3. A load. The load will consist of resistors, capacitors, inductors, diodes, transistors, and other electronic components. Warning: do not connect a battery or power source without resistance. The circuit needs to have a load. Without a load, too much electricity will flow since there's no resistance to slow down the current. This can cause damage to the battery or generator, can cause a fire, or even an explosion. If the conductor has a break in it, known as an open, and there's no other pathway for electricity, the current will not flow. A short is when a circuit has zero or abnormally low resistance path between 2 points, resulting in excessive current. A short causes the load to be bypassed. Since there is excessive current, the wires and related components could overheat and catch on fire. If a computer has a short or an open, the device that has a short or open will fail and possibly cause the entire computer to fail. Usually, You will not be able to see a short or open as readily as these two pictures. All that you know is that the device does not come on, it starts smoking, or it catches on fire. In fact, the computer power supply tries to detect shorts and opens. It will shut down to protect the computer and the user. Electricity looks for all paths available to ground. More electricity goes toward paths of least resistance, and less electricity goes toward paths of more resistance. If you touch a live wire or anything that is charged while standing or connected to ground, you become a path to ground. I think it's easy to say you want to avoid becoming a path of electricity to ground and become electrocuted. A house or building wire system is connected to a metal rod or stake in the ground. The grounding wire provides additional path for electricity to return safely to ground without causing danger to anyone or anything. Therefore, if there is a problem where the neutral wire is broken or interrupted, the grounding wire or third prong provides a backup direct path to the ground. The ground helps prevent an appliance or a person from becoming the shortest path. In the United States AC sockets, the smaller flat prong is the hot connection, and the larger flat prong is the neutral or return path. The third connection is the ground. The ground connection is literally to the ground. You should not connect your computer or other electronic devices to an AC adapter that does not include a properly connection to ground. Outside of the United States, power connections are quite different, but usually include a ground. The figures shown on the screen are two such examples with the ground labeled. The last part of this presentation will be comparing DC and AC power. Computers need steady and predictable electricity to operate properly. Computers, as well as most of your electronic devices, use direct current or DC. Its current flows in only one direction and it has a fixed positive or negative polarity. Batteries provide clean DC power. Computer power supplies and power packs convert AC power into clean DC power. Batteries are all around us. We use them in a wide range of personal and home devices, and batteries supply clean DC power. When power is coming from the battery, it does not have to be converted for the computer. The power requirements of portable computers differ from those of desktop computers because portable computers are designed to decrease power consumption to provide a longer battery life. Eventually, you will be tasked to dispose of batteries. Batteries are considered hazardous material. For example, many batteries use lithium and/or mercury. To dispose of a battery, you should review the Safety Data Sheets, or SDS, which was formerly called Material Safety Data Sheets, which will detail the chemical composition, which will determine the storage and disposal methods. You should also look at applicable laws in your area and look for options to have batteries sent to a proper recycling or disposal site. Alkaline manganese batteries, such as those used with AA, AAA, and D batteries, can often legally be thrown away with other trash without special disposal methods. This option is considered not the most environmental-minded practice. You should consider sending these types of batteries to a proper recycling center. It should be noted that not all AA, AAA, and D batteries are alkaline batteries. Some are lithium batteries and some are rechargeable batteries, which also contain hazardous material. The opposite of the direct current voltage source is the alternating current or AC voltage source, which uses AC power. Its current reverses directions in cycles. Unlike the DC voltage, its polarity changes from positive to negative to positive. The frequency of an AC source is the number of complete cycles per second measured in hertz. Although most electronic devices use DC power, AC power is sent to the house or place of work through the power lines to the AC power outlets. For the computers and electronic devices, you'll need to convert the AC power to DC power. The reason that AC power is sent through the power lines is because it can be sent more efficiently than DC power. In the United States and Canada, the voltage sent is between 115 and 125 volts at a frequency of 60 Hz. Most countries outside North America use 220 volt electricity at a frequency of 50 Hz. Don't provide 220 volt electricity to a 115 to 125 volt device, since this will most likely damage the device. The AC power outlet in the United States has 3 wires leading to 3 connectors. The smaller blade is the hot wire, while the other blade is the return. The center prong is the ground. To test a power outlet, the voltage between the 2 slots should be between 110 and 125 volts AC. The voltage between the smaller slot and ground should be the same voltage as measured between the 2 slots. Lastly, the voltage between the larger blade and the ground should be 0.5 volts AC or less. You can also buy a $10 to $20 outlet wire tester for a quick and easy test. Question: fill in the blank. For electricity to flow, you have to have a blank circuit. Answer: for electricity to flow, you have to have a complete circuit. Question: what pushes electricity? Answer: voltage. Remember, voltage is the force that causes electricity to flow. Question: what is the third prong used for in an AC plug? Answer: ground. A grounding wire provides additional path for electrical current to return safely to the ground without causing danger to anyone or anything. Question: what is power measured in? Answer: watts. Question: what do you call when a circuit has a cut or break in the electrical pathway? Answer: an open. Question: what do you call when a load is unintentionally bypassed? Answer: a short. Question: what is it called when you have too many devices plugged in where enough electricity cannot be provided? Answer: an overload. Question: what kind of current is provided by a battery? Answer: direct current. Question: what kind of current does motherboards, processors, RAM, and hard drives operate with? Answer: direct current. Question: what type of power comes from the wall outlet? Answer: AC power. Question: how should you dispose a battery from a laptop computer? Answer: refer to the safety data sheets or SDS, formerly called material safety data sheets. Question: what is cycles per second? Answer: hertz. For more information about electricity and electronic components, please visit these sites. In summary, electricity is a form of energy that occurs naturally and such as in the form of lightning or is produced such as with a generator. Electricity is one of the most widely used forms of energy that is used for lighting, heating, and cooling homes and powers televisions and computers. A conductor is material in which current can flow easily. Most metals are good conductors, including silver and copper. An insulator is a poor conductor of electric current. Voltage is the force to move the electrons generated by the power supply or battery. For electricity to flow, you have to have a complete circuit, which creates a loop. A circuit can be broken down to its elementary blocks of power sources, such as battery or power supply, the path, such as wires or metal traces on a circuit board, and a load. If the conductor has a break in it, known as an open, and there's no other pathways for the electrons, the current will not flow. A short is when a circuit has zero or abnormally low resistance path between 2 points, resulting in excessive current. Electricity looks for all paths available to ground. Power is the rate of energy consumption or the amount of energy used in a certain length of time, which is measured in watts. An overload occurs if you have too many devices connected to a power supply or battery. The power supply or battery will not be able to provide enough electricity to the load. Computers need steady and predictable electricity to operate properly. Computers use direct current or DC. DC power has its current flows in only one direction and has a fixed positive or negative polarity. Batteries provide clean DC power. Computer batteries are considered hazardous material because they use lithium and/or mercury. To dispose of batteries, you have to review the safety data sheets, or SDS. AC power reverses directions and cycles and changes from positive to negative to positive. The number of complete cycles per second is measured in hertz. The electrical outlet is AC power. In the United States, the voltage is between 115 and 125 AC volts at 60 hertz. Thank you for watching this video. The next video in the Computer, Electricity, and Electronics series, Part 2, Switches, Fuses, and Other Electronic Components. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.